Let's delve into the distinction between correlation and causation, a crucial concept in statistics. We'll explore why correlation does not necessarily mean causation. Here is a classic example: ice cream sales and drowning incidents. So, what exactly is correlation? Correlation is a statistical measure that describes the relationship between two variables. When variables are correlated, they move together in a pattern, indicating a statistical relationship. We can see that there is a statistical relationship between the variables. Now let's define causation. Causation occurs when one event directly causes another event to happen. It's a direct cause and effect relationship, where A actually makes B happen. Let's revisit the ice cream and drowning example. Observation shows that higher ice cream sales are strongly correlated with more drowning incidents. The correlation coefficient, represented by R, is approximately plus 0.8, indicating a strong positive correlation. But what's really going on here? The real culprit is often a hidden variable, in this case, hot summer weather. Temperature drives both ice cream consumption and swimming activities, leading to the observed correlation. Beware of common pitfalls in statistics. Spurious correlations are random patterns that appear meaningful, but aren't actually related. Confounding variables are hidden factors that influence both variables, leading to misleading conclusions. So, how can we establish causation? Controlled experiments are one way, where you manipulate one variable while controlling others. Longitudinal studies, which track variables over time to establish temporal order, can also help determine causation. Here's the key takeaway: correlation does not equal causation. Always question the relationship between variables before drawing conclusions. It's crucial to remember this principle when interpreting statistical data. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.